showing and things like that, you know.
Yes. I'm sharing it on Discord.
I will also check the live stream in case there is anything.
I'm gonna restart myself.
Okay. So.
Okay, my audio is just weird. Let me restart computer.
Okay.
Yeah, it's fine. Wait.
Okay, so it's streaming.
Yes, streaming on. Right. Let's check that. Can you hear it fine? All that.
Yeah, it's all good. I think. Yeah, the stream is also good. It has sound and it looks fine. So yeah, nice. Okay, so I think we are ready to go.
Okay.
Well, just wait for Bernie. I think he was.
Yes. Let's wait.
No, Peter, so
Okay.
I'm on. I'm not. Maybe OBS sound driver or something. I don't know. What just happened? Okay.
Yeah, if it's broken, don't force it. Like we have 2 recordings going on right now. It will be very unlucky. Yes.
I mean, yes, but at the same time, I'm
Yeah.
running both, so there are some correlation between the failures there.
Yeah, that's fair.
So okay, so yeah, this should. Do we start now, or do you need a moment to?
Let me just quickly.
Okay, just tell me when you want to start.
Okay.
I mean, we are already streaming on YouTube, but it doesn't matter much. People can skip to it later.
Now it should work.
Okay, so let's see this paper. Also, I see Reinbert is here, but he's muted. Okay. If he is AFK or just doesn't have mic or something. But yeah. What I was even doing. Okay, yeah. So mechanistic interpretability diffusion models, circuit levels analysis and causal validation. We present the quantitative theory of the diffusion model, establishing controversial pathways and mechanistic principles and the generation process.
Yeah. Say what you want to say.
Okay, so that, like, for example, I do want to say that I'm not that familiar with like the details or like diffusion models, and you know how the architectures work and all that. But
yeah. When you train, you first when you trade, you first add in a lot of noise iteratively, and you're making the network learn basically the other way around, reverse diffusion.
That part I understand.
So you
but apart from
yeah,
that, is it just a fancy training objective, or like do like the typical diffusion model people train like have anything different?
Yeah, here I don't think they even train, as far as I understand. They just like do like inference.
But like
they don't.
is it still just like a normal convolutional neural net or something like that?
I don't know actually in this paper if they mention that. But yeah, you can use transformer and stuff. Transformer is usually used.
Yeah, I was not sure if when people usually do diffuse models, apart from the training on the noise thing, they also have do some change on the architecture or something. But I guess you could do that with a transformer or a convolution net and whatever, and it should work. Yeah. Also, I don't know.
Diffusion transformers. No. Okay,
That
whatever. It should be somewhere in the paper, maybe.
I do know that people do like latent diffusion these days, where they
Yeah.
yeah.
Well, state of the art is flow matching mostly, as far as I understand. At
What's
least in video. I'm not sure in images. Maybe it's in images as well, I think. And in a lot of other well, yeah, flow matching is like in a way generalization of diffusion. One paper says, but yeah, whatever. That's a lot of complex math there, but it's fun.
Okay. Anyway, let's going back to this paper. Yeah, so they have synthetic faces and real faces, and they find there is some
Yeah.
distributions. Okay. Okay, but the processing I'm guessing here is they put a real photo of a face and a real or a synthetic face, and they try to do a one step more of diffusion or something like that, right?
Mm,
Or what?
I guess later we'll see in the paper, hopefully.
Okay.
I skimmed it very, very loosely.
Okay, you were just asking in case you already knew. And yeah.
Yeah.
Our investigation reveals that the real-world face processing requires circuits with measurably higher computational complexity. Aha.
Yeah. The definition of complexity they're using is confusing to me.
Aha.
It seems a bit LLM generated. Maybe not. Maybe I'm just too dumb to understand.
Yeah, I mean, I feel like sometimes when a paper seems like it's very confusing and you are wondering that, it's just confusing. Like maybe it got accepted because the reviewers didn't to confirm because the reviewers also didn't understand it and thought that.
I'm
And
not
like,
sure if it's even peer reviewed since it's on arXiv and so
true.
on.
Like
Yeah.
papers are, but the thing is because they have to. People want to try to get into conference. Papers are optimized to look look that they are doing smart things even when they aren't. Like
Yeah.
I did when I was making my paper, I did get advice of like putting more math because the reviewers don't understand it. But I think it looks that if they complain less about the paper, it looks like there are things that they do not understand.
Yeah.
Like that was like okay, this I feel like this reveals something about the the like the kind of mindset that academics have about publishing papers that they don't like. But anyway, going back to this. Our investigation reveals that real world face processing requires circuit with measurably higher computational complexity. Whatever that is, sensitivity, distinct attention, specialization patterns. Okay, with entropy divergence ranging for no idea what that is, but okay. But the distinct attention patterns makes sense across the noising time steps. Across the noising time steps.
Yeah.
There's a
They-
mechanism.
I'm not sure how they got the edge detection and stuff, but yeah, we can see. I maybe skimmed it way too fast.
Attention mechanism, specialized computer laws. It's attention analysis. Yeah, I don't know this entropy thing, but that at least seems reasonable, right?
Mm-hmm.
But that's just looking at attention patterns and seeing that they look different. Intervention analysis demonstrate critical compression patterns were treated that less produce.
Okay. I haven't got to the ablations part, so maybe that's something that's grounds it more.
Okay.
Yeah, the edge detection and like the more abstract features really remind me of the old school CNN interpretability.
But I can see why from the abstract, although it doesn't seem obvious that like it seems like Piper could be slightly interesting. I can see how it's not like if you have high expectations from being like mechanistic interpretability of diffusion models to be some more general thing. That
I was expecting like some sparse autoencoder and stuff, but apparently they just do statistics on the activations. Apparently,
I mean, I guess
think.
they do.
Yeah.
They also look at
So
attention
like,
patterns, but yeah,
yeah,
that's not something that's like diffusion model specific, right? So
yeah. So they could interpret only just pure activations. That's interesting then. That makes me wonder.
I mean, you say you expect the sparse encoders I didn't have it, but that makes me think about Neil and not liking sparse encoders now. And
Yeah. Well,
he will probably
how
think
old is
that
this
it's a.
paper?
A few months
It's
old.
June 2025. Okay,
Yeah.
half, yeah.
So very old. No.
Yeah, very old indeed. Yeah, like yeah. This okay, I don't know. Like the research contributions like section, it just I don't know, it just seems so LLM generated to me. The structure of it. I hope it's grounded. Yeah, I don't know. My LLM detectors are maybe just way too strong recently.
I mean,
Whatever.
I feel like
Can be
a
good.
big percent of papers these days, even if they are like they maybe use LLMs to format the paper and
Yeah,
all that. So
I'm fine with that. I guess I've just seen too many people posting just stuff that's wrong in this format, so my
yeah,
brain is like screaming, even though
yeah.
it can be completely valid.
I mean, we just need to wait for LLMs to get a bit better and for them to be more likely to be correct than the average
Yeah.
scientist. So. It's not necessarily very likely, even. So.
Yeah.
I think I was thinking about that when people were talking about the latest famous guy who went crazy because LLMs and started saying that he has solved the Navier-Stokes equation or whatever, and how maybe in the future people like that, like the LLMs, will just give them the actually correct solutions to the thing.
They are getting better. Yeah, but yeah.
We'll see. Quantitative circuit discovery protocol. We established the first empirical rate framework for intervention measuring computational circuits and diffusion models. Computational circuits and diffusion models. This is the evaluation causal intervention testing. Okay. Quantitative comparison of circuits mechanisms or synthetic intervention solutions. I guess the causal evidence is nice. The statistical, maybe, but I feel I'm already seeing this and being like, you are not a you are not a social, like, I don't know, humanities paper or whatever. And there is a reason why the humanities papers are often bad.
Maybe it's actually a very good paper.
Maybe it's actually a good paper. I don't know. We'll see. Which characteristic the evolution of computation and circuits of the noise in steps? Identifying the state processing phases and features emerging strategies. Yeah. Organizing incorporated compression state relations. I can see how this could be a good paper or a bad paper, depending on details, and we'll have to read the details. Where, yeah, the whole statistical thing could be just bullshit. Or it could be reasonable. Or maybe we won't be able to, we don't have enough knowledge about, to figure it out, which is which. But, yeah. Six are, yeah, this is just what the interpretability is. Diffusion transformers. We don't have that many good circuit discovery methodologies that are really, actually very works perfectly or very well in the normal models. But yeah,
Yeah.
generative model interpretability. Okay. Information theoretic methods. Goes up. Goes up. These are the steps. So they put the images through the noise, but I don't understand. Do they take the images and add noise, but not too much noise that is just random noise, and then denoise them again, or what? I don't completely get that.
They should, if they do just denoising, then they should just, yeah, do the trained noise from diffusion from the neural network. Oh, they have an architecture there. I see. Our diffusion architecture incorporates. Oh, okay.
What?
Unit. I found where they mentioned what exact architecture they're using. In free one. But yeah, like also like in those graphs, you can see how it's like the formatting is broken. That also gave me like the last graph is just merging text at the top. That made me like skeptical. Also, like when they create a feature hierarchy network, I'm confused. Attention, mid-level, high-level, output, input. Low level goes to attention, mid-level goes to attention. High level doesn't go to attention because it's at the end of the layers, I guess. And like, how is it in a hierarchy? Why is attention a feature? I'm so confused.
Yeah, I don't know. I don't get what this graph is about.
Why is input a feature? Is high, like, how do they define feature? Yeah, like, and there you can see the feature hierarchy complexity assessment. And here you can see like we quantify the feature complexity across processing layer using activation statistics.
Are they maybe looking at the features from all of them, like the attention and MLPs at the same time? Like from diffusion? I guess the low level, high level is like some analog for MLP, I guess.
Like low layers, mid layers, high layers. But attention also is on multiple layers.
Maybe like, yep.
And like they say, in the complexity, like defining complexity seems to be very hard generally. And here they just say, so they take the activations and they take a range of it, a sparsity of it, and they just say dynamic range and sparsity measures. They define sparsity. And they just don't define sparsity in any other way. They just say sparsity. Boom, we're doing sparsity. Okay. How?
Sparsity.
This screams LLM generated. This is what LLMs do when they generate equations.
Yeah. I get what you
So maybe this was entirely AI generated.
The paper has lots of things that make you sus. Because
Yeah.
this is kind of.
And this is
Oh,
what
you're
LLMs
right.
do.
There's no
they
definition for sparsity. So it actually could all been fake.
Yeah.
Not all been fake, but some of it might have been fake.
No, and the range also isn't defined. Dynamic range. What does that mean?
There's no appendix.
Dynamic range. That's actually a thing, apparently. Ratio between the largest and smallest measurable values of a specific quantity. Okay. But I've never seen it used in this context.
Range.
Maybe?
Dynamic range. Like I can see ways that you could measure sparsity, but I don't know.
Yeah,
How?
like the OpenAI paper on the sparse transformers, they exactly defined it, if I remember correctly.
Yeah.
For example.
Yeah, okay, but range. I guess range is just the range of activations. They take the highest activations and the smallest activations and take the range, and they multiply it by the sparsity for some reason. Well, I guess this is a measure of the complexity of activations on sets. It is like the range of the activations and by the number of activations that is typically activated or something. I will want to see how they calculate this. I think this measure of complexity is kind of meh, right? Because it's like you. I mean, it's kind of hard to measure complexity. You don't have to proxy things.
They take the standard deviation, they take the range, then take the sparsity.
I'm sure this is better than just taking doing like the norm of the activations, the average norm of the activations, right? Like it should be very correlated with that. It's just this is just trying to find, in some sense, how what's like. I guess it depends on how measure sparsity. If they measure sparsity by taking the biggest amount of I don't know, the biggest amount of neurons or whatever that are activated more than some threshold, or something like that, then you will. This is just like the max norm or something like that. Like this will be not the same number, but like very just the biggest norm thing. The thing with the most sparsity and the biggest range should have like the most norm too. So it's basically the same. And I don't know. They should just explain it. It is kind
I think we're
of
guessing, basically.
if we have to guess the paper, I mean, maybe they just they do explain it later and in some appendix or something, and that's bad. But it's less bad that the paper doesn't mention it at all. So let's give.
Yeah, but like sparsity is mentioned like 2 times in the paper, so
Yeah. Which information
yeah.
from the efficiency between the layers? Mutual information between the two things and entropy.
Information flow efficiency between the layers. Okay.
Not completely sure what this measure, but I mean, this is the kind of thing that could make sense, but I'm not sure.
Mutual
Oh, sorry, I
dependent.
didn't want to do.
How mutually dependent they are, and then the max entropy. Okay.
It
But
is a
like
standard thing. Like,
information flow efficiency. Okay, I guess that makes kind of sense, but like, okay, interesting.
yeah, why? Yeah, okay, I'm not sure why you want to measure that, but okay. Okay. Layer aberration. Pues.
Systematic scaling of intermediate representation. So they do feature scaling apparently. Could they make Golden Gate Bridge close with this way?
Defined pathways. I'm increasingly more in the nil camp of you need for me to trust your fancy theoretical stuff. You need like some concrete example thing where it does
Neil
better.
Yeah.
brainwash you in between. In that 1 week, did Neil come to your home?
Oh,
Give you a
I
powerful
see
picture.
Real Ben unmuted, but if you are talking, we are not hearing you.
I can
Me?
hear Rindos. I can hear him.
Okay, let me. Maybe it's my Discord. Let me disconnect and reconnect a moment.
Hello.
Okay, I can hear you now.
Okay.
Yeah.
Yeah. Okay, there was a
Let me.
discussion then.
Yeah, it was my Discord. Sorry, I already shared the screen, and
Hopefully that
also
didn't kill the live stream.
no, it doesn't work like that, but it does.
Okay.
Oh no, it even still watching the screen, right? Yeah, nice. Like okay, yeah, like it did stop my live stream, but my streaming my screen, but the recording and all that is still because it doesn't on Oracle machine like separated from my computer.
Okay.
Okay, so as I was saying,
Okay. I'm gonna have to.
Oh, only left. Right. He said you had to leave for 10 minutes. Yeah, anyway. Hi, Rambler. What is your takes on this paper?
I honestly don't. Not enough detail to judge. It feels like.
Okay. Yeah, we need to keep reading, I
It
guess.
feels like you have the answers, but you don't have like the work done to get the answers. So that's how I feel with the paper. And maybe this paper is actually good. It just it feels like you got the answers to like a hard problem, and they didn't show the work, so you don't know if you could trust them. So like,
well, how to interpret this is that okay, so the model works differently on synthetic data than in natural data in some way that might be cool, but okay. Ahora que hablo de compresión estadística análisis. This is nice. To be honest, doing fancy statistical tests doesn't increase my confidence that you did the right thing a lot. But maybe that's just me not understanding the fancy statistical tests. Prediction of what? Okay, of the denoising. Okay. Yes. Did they generate the synthetic data with the same model? Procedure generated. Like I'm wondering what makes the model pick on the synthetic datasets with different. What's the thing that's different between those two? Wait. This is the synthetic dataset. Yeah, okay. Totally sensical that the results are very different if it's the synthetic dataset. Bernie, you are like logging in.
Now I'm here. Yes.
Okay. I was saying that okay, so apparently this is the synthetic data set. Yeah, I totally went with why it's different. Like the results are different everywhere.
That's also a thing that made me confused. Like, like a synthetic dataset means something else usually. I don't. Okay.
Yeah, I mean the way it was they were talking, I would have assumed they were making something closer to the real things.
But they say they generate the facial images
Yeah, but to be fair, they did say they generate
using
them with
procedural generation techniques. Okay.
Yeah, I mean this is generated with procedural generation techniques. It's just kind of
And yeah, then they're finding differences in the circuits. At first, I thought they will like synthetic data basically from image models basically, not from procedure generated techniques.
Yeah, for some other model. If it was the same model, it could be that there's also some interesting stuff. But yeah, I mean, I guess this is not that bad. Like, yeah, if your method doesn't find some difference in how the model treats this and this, is probably something. But
Yeah,
it's very pretty bad. But the fact that it does that also doesn't tell us that much.
would make sense that there would be more. More simple.
Data. Yeah, that I guess that's a good like way to test that you just should spend the thing that the model does in this is more simple, and maybe that's a good way to test like your simplicity metrics, I guess.
It's also like from all this information they're giving, I feel like you cannot really replicate the paper.
Data series monitored complexity increase. Yeah, because it's much. Where yeah, here it's different. I guess yeah, here is because on here there are different parts of the images that have different amount of complexity that are more like maybe it's rebuilding the face or whatever or something, and here is more like this at circle, so it's makes sense to me that it's more monotonic. But I'm not sure that their measure of complexity is that good, but yeah. But more in general, like the model is going to be doing on different steps more different things here than here, I expect.
Okay. So in the graph, first, the normal humans are more complex in the denoising steps, and after, they are less complex. At least the
Which is basically that just means they have more more numbers that are like more numbers on the activations that are bigger, or like have bigger range or something across time steps maybe.
standard deviation times range times sparsity.
But standard deviation on what? Like that takes more than one thing. Oh, this I guess on the data set. Like, oh yeah, I guess that they take a lot of images and take the standard deviation of the activations on that position on some layer, or maybe if it's all of the activations. I don't know. And then probably all of the activations because they don't say the layer. And then you, yeah, and then you take the range of the biggest to the smallest activation, and then the sparsity, however that's calculated, I don't know. I'm not sure that's a super like there is some reason to do that. But yeah.
Okay, since it's multiplying, bigger standard deviation should make more complexity. I guess that makes sense. Bigger range should make more complexity. I guess that makes sense. And bigger sparsity should make more complexity. I guess that makes sense.
Yeah, like I was saying, this seems like it should be like it has some linear relationship with the norm, right? Well, maybe not with the standard deviation actually, but I don't know. Something like that.
Range should.
Yeah, range should. And the sparsity maybe depending on how sparsity is calculated.
Yeah.
Because if sparsity is just number of activations that are bigger than some threshold, that still should be. It's not a linear. Actually, not a linear relationship because there is some jump there. It's kind of yeah, there is kind of a relu, but yeah.
Yeah.
But yeah, there is so it's proportional. Like the bigger the sparsity, the big and range, the bigger the norm. I don't know how whether this is that just calculating the norm saying that's the complexity. And I guess maybe there is something you get with the standard deviation that you don't get. Yeah, I guess the standard deviation adds something interesting where you get like maybe sometimes ranges are smaller and bigger. So this is like, I guess if you imagine multiplying the standard like the norm by the standard deviation, you could get an interesting measure of like how much it changes or something like that. Like the biggest, you multiply the biggest. I guess this is like the biggest norm of the data set, right? Because if you count the sparsity of, or maybe the sparsity is average. I don't range. Range I assume is like biggest to smallest. Sparsity, I guess it maybe the average sparsity. Oh, this is kind of a weird measure. I will. Like maybe there's some statistics reason to do it, or maybe not. I would like for them to actually I see that, but is this like one? It is just one person. Focus.
They're using so many fancy statistical tools that I basically never see in Mech Interp papers. That's interesting.
Yeah.
Makes me makes me question if Mech Interp people don't know statistics or if this is a wrong way to use statistics. This paper.
Yeah, I mean, I definitely don't know enough statistics to. At the same time, it wouldn't be. I kind of expect it's the wrong way to use statistics, but I don't know. Like, and also, why not do a paper first of using the fancy statistics on you know non-diffusion models, like normal. Maybe there is. I don't think so. And
We need someone like Neil to make Mech Interp on diffusion models.
I am. I mean, I'm suspicious of fancy statistical techniques in general. At the same time, I feel like people love them fancy statistical techniques and fancy ways of tricking yourself for what I think. Like there is a reason why. Well, why like there is a replication crisis or whatever.
Yeah.
Like you can definitely do good statistics techniques and do things well, but like it's a something where it's easier to make things that look fancy and nice and that sense. I intended to actually ask Claude or something. Ironically enough, is this information with to development? This feature premiere. I'm curious how they find this feature thing.
Yeah. Attention entropy mean.
Such a development, the target
Global structure. Texture analysis.
Like these are things that make sense for it to happen, but I wondering like how do they know it does those things?
Yeah.
Why?
How do they determine that head 6 is sparse, global distributed, local focused? How do they define that in the first place? What's the difference between global distributed and sparse global? Distributed sounds, well, actually that seems to be the difference, right? Sparse is just focusing, okay. What's the difference between local and global in this context? Just looks at the subset? I'm confused. They use all these words but never define them.
Okay, let me. I'm also noticing that a lot. Let me quickly. I want to quickly skim everything to see. Do they at some point start explaining better? Like maybe they. No, they don't. Right. Okay. Yeah. Okay. So this feels like they don't really explain. Like the whole paper feels like locally it reads like it's a some part of a bigger paper that makes sense, but it doesn't actually explain it, right?
The guy who made it has like 3 other Mech Interp papers that are not on Diffusion though. When I looked at the ResearchGate.
Like it, I don't know. Like I could. If they somehow have actually did the work and actually have all the things, they completely fail on explaining them on the paper, right?
Actually, the guy has a lot of different papers in a lot of different fields. What?
Yeah, that's kind of sus. that moves me more on the AI generated theory of this paper.
Did you guys try looking up searching his name online? Because when I search up Dip Roy and then search up the same university, it was like Accenture. Like that's like the work experience he has.
What's that word? Like you can, if you go to Arxiv, like the abstract website, not the PDF website of this, And look at his other papers on ArcSafe. You can see a lot of different papers.
He did neurosci before with the brain Bayesian medical anomaly detection for
That's
brain
really
MRI
interesting.
analysis.
Okay,
This
those
is
might be different people with different names as well. With
yeah.
same name.
Yeah,
Okay,
Indian Institute of Technology. Diproy. Yeah, let's search him up.
Like
Yep.
this, why another reason why this smells LLM generated to me is that often when someone sends me like LLM generated slop basically, or sends it to some Discord, like the text gives you more questions than it answers, and this seems to be what's happening here. It's like giving
yes.
all these words without
Could it not
definitions,
just
and
be a
it
lack
just
of
generates all the
experience?
different questions. Maybe like he ran some code if he did. Actually, okay, this might be anecdotal. Like when I tried, like, told Claude Code, "Hey, interpret this neural net," it started doing a lot of different random statistics. So, and it used like a lot of different
Yeah.
random statistics. Okay, but maybe we're just too dumb, or I'm just too dumb. I don't know.
I mean, even if that was the case, even if we were to dumb, he still failed to actually explain the scene, right?
Yeah,
Like the paper
there's
just doesn't
more.
explain.
There's more feature interaction network I just found. Context, faces, objects, shapes on page 10 of the PDF. Okay. There's another like feature interaction network. Like in practice, we do this by like the attribution graphs. Does he do any attribution graphs between the features? Are there any feature duplications there?
Like
If
the like past papers prey on your sense of feeling that you are too dumb to understand them when they are actually nonsense. So, so I wouldn't. I mean, and sometimes maybe you think something is bullshit, but actually makes sense. But yeah, no. Even if that was the case, it's kind of the guy's fault for giving us this impression by not actually like just completely failing to explain the thing, half of the
Look
things
at
he
what they
said.
did before, though. They did like consulting.
I mean, that's. I mean, I don't want to enter too much into the things, into like credentials or whatever, because I think people can do nice making their stuff without having done a lot
Yeah,
of.
that is true.
But
I also don't like credentialism, yeah. But like,
yeah,
if someone makes something, it should. Yeah, like this seems to
I
be also like, like LLMism is like, hey, let's do Mech Interp. I'm gonna use all this jargon from Mech Interp in
yes.
completely different ways, and it looks like the Mech Interp, like jargon,
Yes,
but
it
like
looks
when you
like
go into
the
details, it
LLM
breaks down.
that probably wrote this knows about making derp, but
Yeah.
it's not, and it's actually creating something that like parts of what looks like a paper, a good making derp paper on diffusion, but it's not actually writing the paper, right? It's writing like some isolated things where you can only imagine someone who actually did the work will write this, but it's not actually explaining in detail. Uh,
They have a robustness and generalization analysis.
I
Maybe
mean, I
it's
don't want to,
like, but if they had
I
a
don't,
GitHub or something, so I could look at the code, that might have been so much better.
Yeah, that's another thing. Zero code, basically. But like, yeah,
yeah.
a lot of research is closed source, so Crows data features and so like
Maybe
how do
this.
they
process. Maybe Claude Code made this procedurally generated thing.
Like in 4.9, they again, like, if I understand correctly, they say, okay, let's measure feature transferability. Let's measure circuit robustness. Okay, cool. How did you do it though? Like, in other words, just okay, we used this measure, we got this result. No definitions, no details,
I mean,
no.
even if the code was, even the whole thing was AI generated, I will still want to, like, maybe they will have soon the LLMs will be good enough to have at least not terrible AI generated papers.
Yeah,
But I don't know. I feel like Claude, when I was the other day telling Claude
the
like to
oh,
interpret a network too, I think it definitely needed my help, and but it was not doing a terrible job of it. But it also was not doing a lot of
but yeah,
fancy statistics. It was just doing the kind of thing I also don't like, doing activation patching
like,
or whatever.
you're domain expert in the way, so you can like steer it to use the methods that actually make sense and define things in ways
Yeah,
that actually
I
make
also
sense.
tell it when it's
Doing
forgetting
bullshit.
parts of the problem. Like, yeah, I feel like, to be fair, I feel like it also generated 3 options and I picked the best one, and like 2 of them are bullshit.
Yeah.
So I mean, maybe a lot of it is. It looks to me like it works, but I doing more of the work than I'm realizing. But
That's a very common pattern though. Like, a
yeah,
lot of domain experts using LMs being mind blown, oh, they are amazing, and not realizing how much domain expertise they are basically giving the LM by
at the
steering
same
it.
at the same time, I think Claude, like the latest Claude, for like small code things is pretty good. Like giving without you having to steer it very much. But a full research paper, not really yet.
Yeah, that that fits my experience as well.
And also that fits like the the like the meter thing, because a full research paper is more than 4 hours for a human.
Yeah.
uh,
Circuit temporal stability. What does that mean? Like, all these words look amazing, and I would love to see them formally defined, formally measured, and so on. There are a lot of great ideas. I would love to see them, like, in a proper paper, basically.
yeah.
Or like in a proper explained paper, or maybe they
Yeah.
actually did it, and it, like, also all the different graphs, they look like, basically, if you tell Claude or most other LLMs to generate a graph, it's also like,
Maybe
yeah,
they did run code, but I guess it could have happened that Claude did do the research. Like they were asking Claude to do the research, and it kind of did a lot of the research, but the person making the thing all didn't understand it and didn't know enough to copy paste things enough to write the paper, right? Or to
okay.
tell Claude to do the paper, where there is actually some non like maybe Claude actually wrote code to calculate those things, and the Claude maybe even makes sense.
Oh. So Claude did the entire thing. This guy didn't know how to copy paste from Claude, and that's why we have a discrepancy of like that feels off. Like there's like 2 papers. The one paper is the Claude paper, and the other
No,
is the
like Claude did the code, and then they tried to tell another instance of Claude to write the paper based on the results. But since the person didn't actually understand the results, they didn't know what to tell the other instance of code to write. So that's why it feels like
and this
Lol.
kind of what's caused this.
maybe
Well,
I don't know. We're kind of guessing at this point, and I don't know what's
But like,
going on.
maybe we could invite the author of the paper and say how stupid we are.
Yeah, I mean, I will be perfectly fine with the author being annoyed and be like, if they actually did. And at the same time, I think even in that case, it's their fault like they fail to explain things correctly on the paper, right? Like, for example, it says this, like the degradation, global structure, taxonomy, whatever. They didn't explain how they figured that out, right?
Yeah. And how they define it also. But it sounds interesting, like global. How do they frame the words?
Yeah,
Yeah, all of the
maybe,
words are very interesting. I would love to see
yes.
them defined and measured.
And maybe the thing is, it would be nice if actually Claude or whatever model did actually define those things, but the person prompting it didn't actually understand them, and so that's why they didn't put the definition. But Claude was doing some sensical thing when he was doing that.
Yeah.
That would be kind of funny, but.
Oh, okay, they have. Okay, yeah. But this sounds interesting to me. Like they have different, like different attention heads, and they say there's local focus, global distributed, sparse global, and structured mixed. Like that would be interesting to have a typology of like attention heads like this. It is interesting to me.
Yes, but what does it mean?
Like what I would
Where
guess
are these
is
attention heads? Where are these 8 attention heads? They didn't specify the layer, right?
Oh yeah, they're here. There is like
Oh, yeah.
7181 for right
Yeah, but like
0.
I wonder like their notating scheme for like the different attention heads.
Oh wait, no, wait. No, because 7. Yeah, but
That's
Yeah, they said
different, I think.
encoder 1.1. So like we don't know like which encoder or decoder. It could have been like the SCE that like they made, I guess, but
oh
like
yeah, it's a
we didn't.
different graph. And they don't explain
It's
the.
an entirely different graph.
Yeah, this feel like there is a lot of graphs and they don't really explain most of them. They just add more things to the paper. So yeah, that seems kind of.
And the temporal dynamics
AI
and feature
generated.
emergence. Like feature emergence, like what does that mean in this context if it's just a forward pass? Well, that I guess like feature emergence, like they're activating is emerging or something. Like I like this measure of temporal dynamics in other papers where it makes sense. Yeah, but here they just we have these phases, but like
But I guess he just took
Yeah.
temporal circuits for diffusion models. I don't understand the reason.
mm, like
Yeah,
temporal,
no.
I guess it's like when you're doing diffusion, the different steps of diffusing, and then seeing which features light up, and I guess by features, looking at like in the old CNN papers, CNN Mech Interp papers, where you just look at what gets activated for what, and I guess doing ablations. Yeah, I don't know.
Like
If
this does
it's
seems
logic.
like it's like optimized a bit to look like it makes sense a lot.
Yeah.
And like the LLM, if it was made an LLM, the LLM that did it knows at least something of what it's talking about, but just it's writing, it's doing very good text prediction of what a reasonable making their
Yeah.
paper looks like.
This
But it's
one
doing
feels like they took the language from like a good paper and they put it in
Yeah,
and they
but
put like random stuff in.
But then,
It's
that
yeah.
sounds like what a LLM will do. But then, like, it soon looks well written in that way, but it's well written not as a whole, but like section by section, right? Where it has this section that in a good paper there will be some other part of the paper of some appendix or something that actually explains it.
Oh yeah.
I mean, to be fair, this could be that this is, I don't know, was intended for a workshop or something, and this is just a summary of a future paper. or something, and then they'll publish the full thing with all of the explanations. But still, that feels they shouldn't. This is not. I don't know.
Yeah, like
Isn't this a
using
workshop?
Mech Interp.
This could have just been a workshop paper.
Oh, if or he has ORCID also. Employment.
I mean, I wouldn't care that much. No, I wouldn't look too much into the credentials. I will look into the other papers to see, like, if he did like publish a lot of other papers that look like this, in a lot of different things. That's us.
I think that was just a lot of different people with the same name. If you look just at the person, he had like causal intervention framework for variation autoencoder Mech Interp. That's like another paper he made apparently month before this one. I wonder if it has a similar structure.
And also, on the other hand, if there is a lot of people with the same name publishing the same kind of papers, that's also us.
Yeah, I think that was just different people with the same name. But this is the same person. Yeah, also with the Indian Institute. I wonder how this paper looks like. Disentanglement. Uh-huh. So there's disentanglement.
Is it similar?
So will he look at some superposition doing sparse autoencoders? Simple interventions, latent space interventions. I sent the other paper in the chat, by the way. Activation patching. Yeah, that's a thing we are doing in Mech Interp. So he explains it. Great. Here it seems just a lot of definitions and then experiments. I wonder if the definitions are vague or not. He's actually defining modular. In this other paper, he seems to be defining some of the operations much more instead of just saying, oh, sparsity. But I'm just skimming it, so maybe not.
I mean, in this one, it seems like a lot of it just he took this kind of silly synthetic samples with procedural generation and real faces and show that a bunch of metrics are different between them. And then he says something about features, but he didn't really explain that or do really.
Maybe like the two papers were meant to be one, and he just split it up into two, and that's why like both feel off.
I don't think so. Interpretability. Yeah, this is talks about features and whatever, but he doesn't. Let me see all of them.
If it was understandable, and it would be such a great paper.
Yeah.
Polysemantic versus monosemantic units. In the other paper, he looks at polysemanticity.
But I still left with doubt that if they had a long conversation with Claude or whatever model to generate this, did Claude actually do good research that out there that the guy failed to copy to explain on the paper? We can analyze the evolution of the computer circles of features.
The other paper kind of looks more legit, but that's also maybe because I haven't looked at the details, so it looks legit on the surface. I don't know.
I mean, that's precisely the problem with stuff.
But like, why are all the graphs similar-ish to the other one? Like, did he like take the graphs from the previous one and just like modified the use case a little bit, and that's how you made a paper?
Or using the same LLM generating the same kinds of graphs. I want to give him benefit of the doubt and just thinking that I'm
Yes.
dumb so much.
Kind of, but I think you should have some uncertainty, but at the same time, you shouldn't. I feel like if you do that too much, like that's how all of the people who making bad papers that look good on the surface, but like people are
Yes.
optimizing to generate it to make them give them the benefit of the doubt in this way. You shouldn't. Yeah, you should. If there is some paper where I think of that, you should be deeply suspicious of it. I mean, you shouldn't be certain that you should have some probability that you are wrong. But
Yeah.
at the same time, it's also the work of the person doing the paper. I don't think it is because you are dumb. If it's that we are not understanding and that they did something and we are understanding, the problem is that they fail to write a good paper that explains the thing correctly. Because, for example, they do this feature hierarchy network. I don't think they explain it or even explain.
Like it looks like the okay. Well, in the LLM writing this paper frame, it's like the LLM is like, the newest hottest method is like attribution graphs, but like I don't have enough like space or whatever to do that, so I'm just gonna make this vague feature interaction graph. That looks like the attribution graph that's in Mech Interp actually done by rigorous methods, and yeah, like
But an
okay,
attribution graph, all you need to do is just get a transcoder or some like maybe like crosscoder and just train a replacement model on it, and then
yeah,
you just use your own clustering method or you human label it.
yeah,
There's code there to like do clustering by like embeddings or by coactivation. I made code to do it by coactivation.
yeah. And here they didn't do any of that. They just throw statistics at activations apparently, and
I
like the
don't think
features
they
make no
explain what
sense.
they I don't think they explain what this is actually. Like, yeah, for example, this feature interactive network. Yeah, this is very nice. How? Like, how do they know there is a feature that's an edge, a feature that's the same? Like, if you did a attribution graph, you will get some. Maybe you will get something that you could
Like,
represent in this way, but
yeah,
they don't. They don't
the first
explain how they figure that out. So that seems bullshit.
edges, textures, shapes, objects, faces. It's
It's not an
features that we
attribution graph though. What they did was not an attribution graph, because if it was an attribution graph, they could have talked about the neighbors or like the.
They don't explain where they got that graph from, as far as I can tell.
and
And
yeah.
this looks like something that you could have made some method and actually made the graph, but that's all what you will expect the LLM to do if it's trying to make a paper, because in the internet papers actually did the methods, but the LLMs hasn't actually done the research, so it has to generate something that looks like what someone who knows what they are saying will write. Yeah.
It feels like this goulash of like, okay, let's take something from CNN Mech Interp, something from LLM Mech Interp, something from rigorous statistics, and just mesh it all together in something that semantically kind of makes sense, because that's what LLM seems to be mostly doing.
At the same time, I do wonder if some of the statistical things, like some of the ideas of running that kind of statistical method or whatever, is actually something that will make sense to actually do, right?
Yeah.
Like the LLM knows more statistics. If it was rated by LLM, the LLM does know more statistics than us, and maybe it has some interesting idea about how to there's this kind of thing. But maybe, but I don't think they actually don't necessarily run the experiments. And I don't know, maybe it does make sense to calculate complexity in this way for some idea of what is some measure of
It's
sparsity
interesting, yeah.
databases. but no, at least sounds like it makes sense. It's kind of weird in some way, but it might sounds like it makes sense. Maybe there is actually some established thing of measuring complexity that way, but
I
it
tried
has
to
some
Google it.
but
Nothing.
has some actual, or it makes sense for some other reason, but didn't actually write something that makes sense. And again, if it was writing my LLM, maybe the LLM actually said something sensical when it explained what the range and the sparsity is, or maybe it's not sensical, but it's almost sensical in defense in some subtle way. But the guy didn't summarize it here or whatever, or told it to summarize it for a paper, and the LLM failed to explain range and sparsity. I don't know. It's kind of
yeah. And is the information flow used somewhere?
Information flow is a thing, apparently. I look it up and
temporal circuit evolution.
it's
Distinct
kind of
patterns.
I don't know
Okay.
why you will. It seems like a very vague statistical thing of mutual information between layers, and I don't know why you care about that measure specifically, except to have more statistics on your paper and make it sound fancier. Like I could see ways where you use it for something real, right? That kind of statistical measure of like how related two layers are or whatever. But here it doesn't actually, explain why they use it or how they use it and why it's important and what does it even mean in this context. It just here is information flow. Have fun. Do they even have any graph actually? Information flow. I guess information flow.
I think in figure 1 they somehow use it. And information flow efficiency matrix.
Okay.
Information flow efficiency.
It's just to show that the synthetic data and the non-synthetic and the real data are different in this information flow thing. It's okay. Makes sense. Maybe.
It's interesting, how does it differ from the different time steps though?
The data
If the graphs are actually from real data and not just hallucinated. Sparse global. Uniform distributed. Okay. Attention specialization time step.
Like it makes sense that the graphs are differently.
I'm confused about the attention specialization synthetic. You see the on the bottom, the x coordinate. Attention layer 1 1 1 1 1. Is that a hallucination?
Maybe.
Should it be like 1 2 3 4 5 instead?
Probably.
Okay. What?
Well, yeah. I mean, like, out of context, I could see a human making, maybe asking an LLM to make a graph from a real paper and getting that thing. But like with the rest of the thing, like the evidence does pile up. And we can do inferences about things based on evidence.
Yeah. I mean, like, I think actually, like, now everyone should use LLMs to make graphs at this point, but from data that they know that it makes sense. But like, who would code manually graphs right now with LLMs? That's something that's easily automated. If you know what they're plotting, it makes sense.
Oh yeah, I mean, I do like for a lot of the things I'm doing, I just ask the LLM to make a
same
plot because it's not. Yeah, but I know what the graph is a graph for a real experiment. And sometimes the code I code the code for the experiment anyway. I do read it later because I might need to make sure that the model didn't do something wrong. But it's a real experiment on real data. This might actually be a real experiment on real data with the real diffusion model, even if it's AI generated. But still, that doesn't make that mean that the thing makes sense.
And they say they say they have the architecture. I still wonder if they like they generate if they
but this
if they
feature,
train on the images or
the part where they talk about features and edge detection or whatever, that seems very made up, or at least they didn't explain
like
why.
it sounds like what you're doing in like the first basically the first citation is like the zoom in paper from Ola, so it sounds so much like that paper, like looking at like the CNN layers, and like if they would find, I don't know, the what were the features, like I think human yeah, like the different human interpretable features.
Yeah,
They have
but
it in
there
some
they
graph. Yeah.
found it manually, right? And this
Yeah.
they didn't here
That
they don't explain it. They just kind of similarly made it up.
yeah. They have like edges, textures, shapes, objects, faces, context. Like as like features apparently. Yeah, that's like the feature this like in the zoom in paper they graph those like and show, oh look, this looks like a measuring shape. This looks like measuring a face. Like they graph the activations and you can see it in that. So even if you don't train any like sparse autoencoder or stuff like before all of that
So
on the
yeah, you're saying
CNNs.
this graph is made up by by copying the other paper, the Chrysola paper, where they did
Yeah.
find edges and shapes and textures and
Yeah.
objects and faces and context. But here they are just making it up. Yeah, that makes sense.
Maybe they are not making it up. Maybe they are. Yeah.
I mean, I don't see like on the explanation where they didn't make it up. I don't see why they wouldn't even explain how they figure it out. Right? They're just saying it. At minimum, that seems really bad paper writing.
Yeah. Like I can maybe see like yeah, this seems to be like mostly like the Chrysolach papers combined with some like rigorous statistics papers from other fields, since okay, ML is terrible at statistics generally. And like yeah, combined with like some LLM stuff as well, some LLM interpretability, since they are working with transformers. And like like they are talking about temporal analysis. There are like papers actually doing that. Like we did one of that before. Phase traces, like they talk about the free phases. You see the free phases? Do you remember that one paper where we looked at the evolution of features? It also found free phases, but that was in model training. Here they find free phases in diffusion denoising, which is inference. If they actually find it, so like
Yeah, and there could be three phases in diffusions, but
yeah,
we don't. At this point, we don't trust this thing to not be completely made up. I guess apart of that, there are multiple levels of how made up it is, right? It could be more or less made up, or more or less AI generated. Even if it is AI generated, it could be the AI running some experiments on code, or it could be it completely making up the graphs. So yeah, I don't know.
I'm just imagining the author watching this video and was like, no, I just forgot to put it in. I don't know.
Also,
Yeah.
okay,
Oh
so
my
here
god.
talks about sparse, global, and uniform distributed. Okay, that they didn't explain that either, but that will make sense in that, I guess, sparse global. But I don't know global means in that context, but I guess sparse is
They have more of these.
yeah.
In one of the graphs they have.
Yeah, here sparse global.
I like this actually. This is like the attention head typology that would be very interesting to see.
Yeah, but they
Where do
don't
they
put
have more?
any explanation
Yeah.
or thing on what that is. And that's
Yeah.
just like a good thing to.
Like
measure.
Well,
I guess they mean like. Well, I agree with you. I don't know what local and global means in this context.
like
Like
I
distribute
would,
and focus does make
yeah.
sense.
Like I would say that like local focus is like when the attention head is just looking at one part of like previous context on one like small subset locally, just basically focus on just
Yeah.
that basically. And like that then they have sparse global. I would say that's like looking at various sparsely at like various different parts of
Yeah.
the context, and then they have global distributed, which would be like uniform almost like in the limit, and then they have structured mixed heads, so that would be like a mix, some weird
I
mix of
guess
all of
that
these somehow.
part could be something they look a bunch of attention patterns manually and they show those patterns. But yeah,
Yeah.
uh, I will. Even in that case, I will just put some images of the attention patterns to
And
or
like
explain what I mean. Actually, explain what they
Mhm.
mean by that there somewhere.
like and the entropy makes sense. Like if you have local focus, yes, entropy should be low. If you have global distributed, yes, entropy should be high. That makes sense.
Yeah.
Under the definitions, that would make sense to me.
Yeah.
So we're
Unfortunately,
guessing it.
the LLM might also be guessing, and it's good at guessing, and it knows what entropy is, and if it's
Yeah.
distributed, it will be higher and lower. Or maybe it did run some experiment, like on some data, and they didn't explain it.
Yeah.
Like, I
But
mean,
like
LLM
what?
generated doesn't necessarily mean completely made up, but still.
But like yeah, like why
And
is
they do
this periodic pattern?
the important
Yeah.
importance ranking. I guess they do ablation maybe. They even explain that. Ablation intervention impact. Okay, yeah, that makes sense.
Yeah, it makes sense if they did it. That's another ask question. It
That
makes
part
sense
does
to
make
predict
sense.
it like that. Yeah, okay.
But there are other parts that just seem completely made up, right? Like the thing that is global structure, texture analysis, and all that.
Then they have like attention head correlation matrix on that graph that we looked now just before, and like every time you ask LM to do something, it generates correlation matrices all the time. So I'm like, okay, did they say, hey, make it more fancy? Oh, yeah, one more correlation matrix. Does it say anything? No, but it looks fancy. Or maybe it's useful. Revealing functional dependencies. Okay, but like it doesn't. Like, and the circle of pattern is interesting. Like, if this is real, then like, okay, head. Why is it like this? Like, head one is this. Head 0 is the same as head 4. Head 1 is the same as head 5. Like, that's circular. Another circle if that's real.
Like
Why is there no?
I want to say that yeah the paper could both be real and LLM generated. Like it could be a vibe coded paper.
Yeah,
And
basically.
that's a vibe coded paper is better than a completely made up paper. In that maybe some of the graphs are real and the actual there were they actually did the thing they claimed to do on the actual model, and we can learn something from them. But the problem is we can't trust them because
Yeah.
especially not with them seeing the actual code. Uh,
Maybe it's easy to reach the guy.
I'm not sure I feel
Yeah,
like doing that, to be honest.
yeah, same.
I mean,
Like
if they
yeah.
watch the video or something searching for the paper and come to complain, I feel free to talk to them. But
They have correlation matrix between complexity, entropy, hierarchy, and impact. Okay, that makes me very confused. On page 6.
what do this think us about the less brown stuff about noticing your own confusion and
Yeah.
your research skills depend on your ability to be more confused by fake papers than.
That makes sense. I would be really interested what if this would okay. Kind of like
if making a better version of this paper that actually run all of the things and explain everything. Like would be nice to see the good version of this paper.
Yeah. Also, yeah. Like the correlation matrix. How how are you measuring correlation between hierarchy and impact? The more impactful, the more. Okay, I see now. Those are like different variables. Why do they correlate? Wait, what? Why do all of them correlate? Okay. All of them have positive correlation. Complexity is correlated with entropy. I would expect the other way around. Hierarchy is correlated with all of these variables, the complexity, entropy, hierarchy, and impact, all of them correlate. Apparently.
So
that is interesting.
Here, feature.
Oh my god. Feature emergence timelines for different abstraction levels.
Yeah, but how do you know what features? What the features are they talking about? How do they get the features? That's the main.
We are in why do you? That's another cooperation mate. Cooperation matrix. Wait, what? Hold up.
No,
that should be correlation, no?
No, but it's circuit
cooperation.
But it's circuit, like it may be how the circuits, like there are different circuits, and they, I don't know, and they.
Like if you ablate to one, how much it affects the other one,
or something like that, yeah. But yeah, that they don't explain, as always. They don't explain
showing
it,
interdependencies. Okay, cooperation matrix.
How much
That's interesting.
the element that probably made this up, like how much did actually think something like that versus create something suggestive that it's making us embed something like that.
Interesting.
That
would be interesting if it would be more explained.
That's like the whole paper.
Yeah.
But also, yeah, the main thing here I think you complain is how it talks about feature emergence and a lot of things about features, right? In no
and
point,
phase transitions.
In no point the paper talks about, here says about, feature emergence pattern.
From edges to textures. Like it makes sense that would happen.
In no point they actually explain how they talk about features. I guess they could mean they look at the images and they talk about how certain features on the images like start showing up or something, like fair edges, then
yeah, like I see that would make sense. That would be a thing.
But how do you plot that? Right, because I can see how you look at this, right, and see that. Okay, that's a theme. First, it does the edges and all that, right? But how do you calculate feature emergence and things like that to plot in? Like how do you figure out there is some feature that's not manually by looking at it?
I would just do a lot of ablations, basically. Like delete this, suddenly edges do not form. Delete this, suddenly some textures do not form.
They didn't explain how they find the circuits either. right? Or do they just
What?
they talk about circuits like
Okay.
right?
And like they say circuits and features and like don't distinguish it. I feel
they
like
don't
sometimes.
they don't explain, like they talk about circuits like the abstract and everything, right? They talks about circuits and whatever, but they don't do anything related to circuits. They just look at a few attention heads, right? They talk about circuit analysis, but they don't explain any circuit analysis. They talk about circuit methodology, and so this is circuit discovery methodology, right? So they have this attention specific quantification, okay? Featuring hierarchy complexity is assessment. Information for
It's also
analysis.
feature hierarchy.
Yeah, intervention protocol. They do interventions. I guess they do interventions. They don't. They do talk about doing ablations, but they don't do the part where they. Okay, but they didn't do.
Then they give some like percentages of like, okay, that's how it could have happened.
But it doesn't. They feel like there is a step missing here. Like they are not drawing the rest of the owl. Where you so you have some measure. You have ablations, right? You have a bunch of different ablations, right? Which makes sense. This is totally the kind of thing that if you ask Claude, tell me a few ways of doing interventions on the thing. We'll tell you things like this, right?
Basically, it's like output from Claude.
But
Uh,
like you will say, layer ablation, limitation percent. Yeah, this kind of feature scaling makes sense. Like Claude will say feature scaling, but Claude will mean feature scaling because Claude will expect you have a Sparse encoder, right? And it
I
will mean
think
to
you
do
don't
that.
like. Wasn't there some feature scaling in like the old CNN papers where you just like increase the activation, the like neurons?
Okay,
Like
that makes sense.
when
But
you
there
don't
they were
when you
assuming
yeah
a specific neuron was some feature.
yeah
Right.
like when you have monosemantic neurons in some very limited contexts in the old CNN papers.
Yeah, but this paper
Which
doesn't
I don't
explain that. It
think.
just doesn't say anything
Yeah,
about that. It's just feature scaling. But the thing is,
yeah.
this is nice applications, right? But they don't explain how to make a circuit from that, right?
Yeah, like circuit isn't defined. They're like, oh, here we have these circuits and features.
Like,
And
like there is when you are doing something like ACDC or whatever, when you're doing circuit, we're trying to get a circuit from the from some neural network. You need some way of systematically doing ablations to find the circuit, right? And
yeah,
prove which parts are part of the part is not. They don't do that. They just talk about doing ablations, and they in the way in the imaginary world, in the world where they did do the research, they talk about they will do a bunch of layer ablations and they want some ablations and then find some circuit somehow. They didn't explain how. Okay, and then they kind of talk about a bunch of different circuits and cooperation between them, whatever that means. Like there is some attention, some features, some spatial, some semantic circuit, right? But
hmm
the people at any point says, okay, we did this thing and then we found these circuits, right? It's kind of missing a step. Like on the second part of the paper is like kind of hallucinated that they did that research and they found these circuits and that right. I should explain. There is and those circuits seem mysteriously to correspond to the thing on the Chris Sola paper, as you said.
yeah.
So,
Well, not these ones. Some of the other features.
oh yeah, here,
Yeah,
yes, the ones here, and but the paper is missing some part where,
but
in the middle
it
where
would
it
make
says
it would make sense that there will be like universal features across vision models like this. But yeah.
But yeah, the paper is missing the part where it's in the middle where it says, okay, so we did this method, we ran these things, and we found this part where it has these circuits, and it does that.
How
And
many
like
times?
it's not even they didn't explain how they did it and all that, but they didn't even explain the method, right? The method is missing the part where you do the, like, I could see a method where you kind of manually do the ablations and can say, okay, I think there is some circuit there because I spent some time looking at the graphs and doing ablations and I found this out. I made my own paper is kind of like that, right? But I didn't.
Yeah. You can see how one feature, okay, one circuit is called attention, another circuit is called feature.
Yeah, that's
What?
also, that wasn't always thing. That's kind of very sus. But
That's
I
very
think,
sus.
I think it's
Spatial, semantic, detail. Okay, semantic is like abstract, detail is like concrete detail. Spatial is like spatial, like it. Yeah, it vaguely could make sense.
it
Just
could
like
make sense,
LLMs
but
generate text.
the paper doesn't actually explain at any point what those are, right? It doesn't talk about it. It doesn't say, we ran this method of ablations on the model and found that there are these. There is a feature circuit that does this and that. Doesn't actually mention that or explain that. It seems completely hallucinated.
Yeah. But
also, I feel like it's very funny how long we spent like analyzing the paper that was likely fake. It's kind of I think it's a fun exercise to try to
actually,
look into a
yeah.
fake LLM generated. You probably get better at figuring out when papers are sourced by.
Do you know AI Vixtra or do you know Vixtra? Vixtra is like archive, other way around. Like if you reverse the word archive, you get Vixtra.
Yeah.
And that's a website where people can post papers that are not accepted to archive. And then there's AI Vixtra, which is like basically LLM generated Vixtra. That people can post stuff there. And there's like one guy on YouTube that just goes through the mathematics section and is just reading all of the LLM generated stuff and just roasting it all the time.
It would be funny to one day do a thing where we have a bunch of papers that we don't like, that are real papers, and papers from there, like from maybe Mech Interp, or like maybe we can generate it some other way and see how fast can we make a game where how fast can we distinguish them.
Yeah, like Elutra AI, for example, like the Discord, there's like every few days someone comes in and posts some LM generated paper convinced it's revolutionizing everything. And people, and sometimes people like are dissecting it, but they're like now at this point they edit like pinned a message saying that the effort to like I think that's some law someone said, like the effort to debunk bullshit is much more. You need much more than to generate bullshit, basically.
I guess we'll soon have, as language models get better, maybe we'll can use them to debunk bullshit more efficiently. And people generate, and in the limit, we'll see what this reminds me of all of the Paul Cristiano stuff about, like, debate and whatever.
At the same time, if you make like like anti-suffragette take, you get the exact opposite, basically local minima. So like
the question is, like, this relates to all of the discussions that were about the debate stuff and Paul Cristiano stuff, interpretation stuff. Like on the limit, what happens? Does the limit, and since the humans are like get the right explanation because it's
Like-
easier to debunk the bullshit than it is to, or does the limitants if everyone is super confused and we completely lost our ability of figuring out what's true or not because it relied on not being easy to generate a lot of bullshit.
Like kind of the other extreme, the anti-suffocating attractor, like it's generating plausibly sounding criticism that makes sense on the
Yes.
first glance, just like it's now generating plausibly sounding things that make sense that are the opposite of criticism, and then you have to debunk the
I actually tried
debunking.
once. I think it was nice, like the sort of. I tried. I don't remember what I tried. Asking something of Claude, and then it ask it to to say why its previous explanation was wrong, and then say why the
Yeah.
previous explanation wrong, and then for a lot of steps. At some point, Cloud was acting a bit annoyed at that, and kind of.
I tried this other sort of stuff as well. A lot of and like at one point I tried like something like now be as adversarial as possible, like no yes manning, no significance and so on, and I got
think
into the extreme
also the models are getting increasingly good, and it's kind of hard to say in a neutral way, tell me what you think about this thing without you especially if you have to answer some extra question about the thing later or clarify something. It's hard to not leak to Claude what your actual opinion is somehow. To be fair, also the models are not completely syncophantic these days. Like they are still, but they are not 100% syncophantic, and they don't.
they had to
They
tune it
sometimes
down a
disagree
bit.
with you.
Yeah, they had to tune it.
They are not as bad as the ChatGPT 04 or whatever that was.
Oh yeah, definitely. Yeah, they learned a lesson a little bit. It was too much, but then they tuned it a bit. They first overcorrected, made the GPT 5 way too cold, quote unquote, for people, and then they increased the sufficiency again
Also,
because
to
they
be
were
fair,
losing customers.
humans also have the bug of if you ask a human to tell you why a paper is right, they will make they will come up with reasons.
Yeah.
Like here we are coming up with ways this might make sense, and I may think I'm pretty sure by now that it's just generated.
Yeah.
It does feel like some of the things I said. I said at some point why this thing on this graph makes sense, and maybe it's completely made up. I just kind of hallucinated some Sessica something.
It's something that would make sense if it would be a result that's more explained with code, with like models or whatever, with explaining the features and so on.
But if
I
we
would
saw
believe
the
such a
opposite
paper.
graph, like where this, I don't know, swap or something, we'll come up with some reason why it makes more sense for the real data to be less, you have less complexity on the activations or something. I can actually imagine an explanation for this. Like, oh yeah, but in the synthetic data, it has to notice that it's synthetic. I don't know.
Yeah. What confuses me is that suddenly it switches. I would still expect more complexity overall in
I find this
the real data
thing
set.
really funny.
Yeah, it's like funny. Yeah.
Also, they didn't even bother to put the.
Wait, I think I found another issue. In the feature hierarchy network, the graph is directed. You have arrows. In the other feature network, there are no arrows. There's I think, feature interaction network.
But this is
Feature
interaction
hierarchy
and
network.
the other, yeah, there are different things, right?
Okay.
I don't know what they are. Right?
I don't know how they got this graph though.
Oh yeah, they
Well,
don't
we are
explain it.
sorry
They
now.
seem completely. I mean, I think I know. They asked Claude make some nice graphs that shows. Like,
Jesus.
it seems completely made up. Like it doesn't.
But like,
Nothing on the paper explains what this is even about, right?
like even if you make feature interactions, you still need to do a direction, I think. Like one feature somehow interacts with the other.
And that is still the biggest thing on the question paper. What features? What are you talking about? Did you sparse the code? Did you what are you? Yeah.
Yeah.
Like, at no point the paper talks about any methods that will let me, unless they are assuming, unless they are assuming that neurons are features.
Like I would expect it's like they looked at neurons correlating with the different activations. With like the different data sets. So like this neuron activates only on like
Yeah, but
most feature, like in
that
CNN
makes
papers.
some sense. Then it's bad. Like then it's bad research because
Yeah, like
the
for
features are not
yeah,
the neurons are not monosemantic.
like in the old CNN paper, you could if I remember correctly, you could find monosemantic neurons.
Yes, but
In
they
the old
found a lot
Chrysolite
of
papers.
they found a lot of polysemantic already on
Yeah,
that, and that's why what they realized they needed to do something like dispersed encoders.
yeah,
Precisely
yeah,
because the
yeah,
original paper was failing a lot because they keep finding that a lot of features, a lot of neurons were just not monosemantic.
yeah. So like in this
And a lot
paper, I
of
assume they just skip that step and were like, oh yeah, let's just analyze monosemantic ones.
and
Did
even
they
on the
mention it?
one of the ones on the original
No.
Solar paper were not monosemantic, right? They just had some direction that kind of correlated, was kind of the direction of that neuron, but they did find that it also did other things, right?
Mm.
The dog's neuron also did poker, and that's what they or something like that. And there was some like poker. No, what was this some other cards or something, and they made they put the image of the dogs playing poker for the meme or something. I remember something like that. Maybe I'm hallucinating this. I don't.
Maybe.
Yeah, they find something. There were some news that were more semantic. So even then, it was not great. It was noticeable enough. They kind of the whole polysemanticity and the sparse encoders agenda kind of came from that.
Yeah.
But it's not the thing. That was reasonable when Chris O'Lan did it because basically nobody had actually tried Mech Interp. But they quickly realized that was not the way to do things, and we now know that's not how you do things.
Yeah.
Yeah, so you just should end.
Now we have all the ways to make it a bit more monosemantic with the sparse autoencoders.
Also, I don't think funny. They didn't even do all of the fancy. Is it me or do they not even do all of the fancy statistics? Like they talk about that fancy
They
statistics.
say they do it and then they give percentage and they don't even define it, but like
Where's the
like
statistics that you're talking about? All they did was show graphs that are seem
well,
to be AI driven.
there's one section where they say a lot of statistics. It's like, yeah, it's like if you ask LM what are the most rigorous statistical validation tests, then it will give you this list that's in some of the section. I
Yeah, but
think
did
it's at
they
the
actually
beginning
put
somewhere.
the results from that list anywhere?
That okay, we can double check that actually. Oh yeah, statistical. It's free on the page 5. That's like where they mention Cohen's D with categorical interpretation. Kologomov's millimove test, Berfouli adjustment.
Yeah, do they even calculate
Those are
those?
real things.
Yeah, I mean, I totally believe the LLM calculate, but I don't think
Okay.
do they even
Okay, they
calculate
mention
it?
it. Okay, it's just nowhere in the paper.
I think this
No.
is not even. This is badly generated, right? Like the guy didn't even check it, right? Because if I was trying to make a paper like this, I would at least try to look that I put graph for all of the methods that I mentioned on the paper, right?
Okay, they at least use the Cohen apparently. Cohen's the effect size method. At least one, but the other ones don't exist. So there is no Bernoulli. There is no multiple comparison correction using Bernoulli adjustment. There is no Kolmogorov-Smith test for distribution comparisons, whatever that
Okay,
means.
maybe the LLM is right that running those experiments, I don't know enough statistics to know, will be a good idea. Maybe we should be doing that on Mech Interp papers. But yeah, no.
Yeah.
But you need to actually do them.
Oh my! There was also an archive. There was some drama that because of a lot of LM generated papers, there's like harder to get a paper published now, as well. I'm not sure if you noticed that drama.
Okay.
Like 3 months ago, I think. Yeah. And also neurips. I guess that's happening everywhere right now in science. And now we're like in the LLM space, so we know how LLMs work much more than the average people. At least I like to think that. Well, I think that's true. And
I feel like we're tricking ourselves
yeah.
that we know more. We don't know more, in my opinion. Or like, I feel like it's more of a trick. I don't think too much more.
Like, I every time I see someone outside the field use LLMs, I'm screaming because they don't have zero idea. Often, I don't know. Yeah.
Conclusion of this paper is.
Oh my God, this is interesting paper. But it gave so much ideas. Like it's interesting. Like you could do this. I might try to do that.
Yeah,
like
I
some
mean,
very small diffusion model and doing this like time step, like training sparse autoencoders on the activations essentially, and then looking at what features slide up on the different time steps and see if they're like
but I mean,
there's
I
like some
think
phase shift or something. That's
I
so
think
interesting.
actually asking Claude for ideas of things to do on a paper to do research on diffusion
Yeah.
memories is a good idea actually, and you should. Yeah, you should actually try to do that and to getting ideas from. It can generate good ideas. I think what you shouldn't do is try to have it do all of the work.
Yeah.
Because then it will do things like this where it
Yeah.
writes it measures the thing and never actually runs the test because it forgot that it existed.
And maybe the test makes sense, but yeah, I
And
haven't
maybe
seen
it
it
makes sense.
before.
I don't know enough statistics to know it. And I think AIs know enough statistics that well, sometimes it makes they say it doesn't make sense because they make some reasoning mistakes. But that it could probably tell us if we ask that it makes sense and get a whimsical answer. But yeah, no.
Yeah.
I'm curious what happens if you copy
Mathematical.
paste this paper into Cloud and just ask what it thinks about it.
Yeah, let's try that actually. Like, that's a good idea. Do you wanna try it on your? Yeah, I think you're sharing only the PDF or not. No, you're sharing the whole. Okay, that means you could download it and make a new
Oh, I
tab.
can just give you the if you want. You can just go to the link on the right.
Yeah. I mean, I'm like if you wanna make it on the stream, so we both see it basically.
Okay. It's for the I'll do it. I'll download the PDF and send it to Cloud or whatever. Yeah, let me.
I do wonder if Claude will say something similar, like we've been saying now the whole time.
I mean, maybe Claude will be fooled by the fancy.
Wow, this paper
Okay,
is
wait.
absolutely correct.
Downloads. How do? Wait, kind of dumb. How do you do? Oh, save. Here.
Save.
Yeah. Let me.
This doesn't feel. I think we should end it. I think we're now just going paper critique instead of paper.
Yeah,
I
I
mean,
guess
that's part of it in a way.
Yeah, maybe we should end the stream at least.
I feel like
Yeah,
we
okay.
are paper roasting. I feel like this is not what we normally do.
I think. I mean, to be fair, we normally don't read papers that deserve that much roasting, but
Yeah. Like, I
Anyway.
chose this paper because it sounded so amazing, but then you
yes,
look at the
but
details and
the
it's
other
flop.
hand, that is kind of a sign of there's probably the most amazing sounding papers are fake, probably.
Yeah.
Like they are optimized for. Anyway, I let the recording and all that. Anyway,
Okay.
it's kind of a really good one for a while, so